All right, so I thought I'd just go ahead and take a look at some solutions to 5.2 problems. So that's with the nullclines 5.2. And so we'll do number one here. X prime equals 2 minus x minus y. Y prime is equal to y minus x squared. And now when I'm doing these, I'm going to use a little bit different technique than we used in the very first video. And that's because I think it's easier to think about these curves. Um, yeah, it's easier to think about the derivatives being just either positive or negative on either side of the curve. So let's see how we're going to do this. Initially, we want to draw the nullclines and then locate the equilibrium. So in this case, we're going to have positive and negative values. And so for my first curve, I'm going to have y equals 2 minus x. And just as a reminder, I'm going to, right underneath it here, I'm going to remind myself that x prime is equal to 2 minus x minus y. Okay. And then for y prime, I have y equals x squared if you put that equal to 0, right? And I'm going to remind myself that y prime is actually y minus x squared here. Good. Now, because x and y, the derivatives of x and y, only depend on one curve, it's fairly straightforward to tell where they're positive or negative. Because, for example, I know that on this line, x prime is equal to 0. That means that's splitting the plane into two pieces. So I know that if I'm above this line, x prime is either positive or negative and stays that way. And then down here, I know that x prime is positive or negative and stays that way. So I need to figure out which direction they go. So down under the line is the point 0, 0, so I could plug that in. And I see that x prime is positive. So therefore, for all points below the line, I know that x prime is greater than 0. And also that means that all points above the line must be where x prime is less than 0. Okay, so I'm actually doing a graphical analysis here, or the sign analysis, but it's just graphical. And it's a little bit easier when you only have one expression here. Now I should say, if I had something like x prime equals x times 2 minus x minus y, then I would have to be careful about my analysis, right? Because I would have to take x into account as well as 2 minus x minus y. And so for this, I would actually have to go through a sign chart. Right, there's actually two variables here in this case. So I'd have to be careful about where things are positive or negative in this situation. Okay. By the way, that's why we were keeping this all in quadrant 1 before. That way we don't have to worry about this term. We could just focus on that term. Okay, but if you have lots of expressions here, then this analysis gets a little bit more complicated. Okay, I think we'll see something a little bit more complicated in the upcoming problems, but for now, we'll stick with this. Okay, good. So there's my two nullclines, and so I've got two equilibrium solutions. We could solve for those analytically if we want. That's for y equals x squared and y equals 2 minus x. So x squared equals 2 minus x. And so x squared plus x minus 2 equals 0. And so we have x minus 1 and plus 2. Will that be what works? Yep. And so x is equal to 1 and negative 2. And of course, that's just the x coordinate. For the y coordinate, you would go back to either one, right? Y equals x squared or y equals 2 minus x. If we take y equals 2 minus x, then our y is going to be 1 and 4. Good. So the ordered pairs here are 1, 1 and negative 2, 4. Good. So those are the locations of our two equilibrium solutions. Good. Now, we said along this line, x prime is equal to 0. What about y prime? Oops, I forgot to fill in y prime. What's happening to y prime? So how about a point inside the parabola? For example, x equals 0 and y equals 1. This would mean y prime is positive inside and y prime is negative on the outside of the parabola. Okay, so for my line here, this is outside the parabola, right? So therefore my y prime is negative, and so in this case we're heading down. Inside the parabola we're going up, and of course x prime is 0, right? That's why we're going straight up and down, and then up here we're going straight down again. Good. Now how about along the parabola? Along the parabola we're going straight across, so we just need to figure out if we're going left or right. And so if we're above the line, x prime is negative, so that means we're going to the left. And below the line, we'd be going to the right. And above the line, we're going to the left. Good. So that's giving us a pretty good feel for what the solutions are doing. They're winding around here, right? So these might be centers. They might be spirals somehow. We'll have to see. Let's see. So then the second part of this was to take a look at a few points. So one of the points was 2, 1. So 2, 1 would put me right here. And the question is what does this point do over time? Well, this point is very close to this line here, so that means I'm going to be moving down, right? And then also what's happening is that y prime is going to be negative. Y prime is negative, so that means I'm moving down. How about x prime? Let's see, x prime is negative, so I might be moving to the right until I get to, well, at some point I'm going to get into this region. As soon as I'm in this region, I'm going to be moving down and to the right. Okay, and so this point, at some point here, since we're moving down, right, we're going to be getting there. So I might be going something like that, unless I get let's see, unless I get caught in this somehow. I don't think I'm going to get caught in the equilibrium, because it looks like I am going to be forced down and to the right there. And so this is just a guess, but it looks like that's what's happening. How about at the origin? Well, at the origin is definitely down and to the right. Okay, and then how about what's the other point we have? 0, negative 1. Down here, I guess, huh? And then where are we going? Well, we're going down to the right there too. Okay, so we're going down and to the right. That one wasn't too hard to figure out. Okay, and so finally what you might do is plug this system of differential equations into that online plotter just to double check that the effect is correct. All right, so that's about 8 minutes. I'm going to go ahead and stop here, and we'll start with the next problem in the next video.